Okay, so if we look at 4.7, which is our inverse trig functions, we're going to start with the definition of an inverse trig function. And so we're going to look at our definition of our inverse sine function, our inverse cosine function, and our inverse tangent function. So let's start with sine. Alright, so if we go over what that means, we use the expression arc to mean the same thing as inverse when talking about sine function. So when you hear arc sine, it's the same thing as saying the inverse of sine. And with all inverses, what we're doing is we're switching our x's and y's. So if y equals the inverse sine of x, then sine of y equals x. We switched our x and y to make it be an inverse. And because of the different domains and ranges on your sine graph being periodic, when you switch your x's and y's, our domain changes to be -1 to 1. So you can only have x values in between -1 and 1 for it to be an inverse sine function. And you can only have y values in between -pi/2 and pi/2. And that just comes from your graph. For cosine, it's the same thing. Arc cosine is the same thing as the inverse of cosine, which means that you switch your x and y, so cosine of y equals x. Your domain then remains the same as with your sine graph, so -1 to 1 for your x values, but your range changes to be 0 to pi. And then lastly, your arctangent graph is your inverse tangent graph, which means your tangent of y is equal to x. You can have any x value for your inverse tangent graph, so your domain's -∞ to infinity. However, your y values have to remain in between -pi/2 and pi/2. So we have any questions about our different definitions? Okay, and then the only other thing you need to know is that if you're given like an inverse sine function, let's just use sine, inverse sine of x equals y. To undo an inverse, you multiply by the regular function. So the inverse of sine is sine. So then an inverse sine and a regular sine cancel. So x would equal sine of y, which is where that comes from. So to get rid of an inverse, you take the original function and you multiply by it. And that works for all of them, so that would work for cosine and that would work for tangent. Does that make sense? Okay, so let's actually then evaluate some inverse functions. So in example 1, I'm given arc sine of -1/2. And I prefer to write my inverse functions using the -1 because it makes more sense to me. Okay, you can leave it as an arc sine if you want to. And so this is like inverse sine of -1/2 equals some y value, because sine always refers to your y's on your graph. And so to get rid of this inverse sine, in order to solve it, I need to take the sine of each side. In doing so, then my inverse sine and my sine cancel, and I'm left with -1/2 equals the sine of y. Right, everybody follow so far? And so if that's the case, then I look for -1/2 as a y value on my unit circle, and I figure out where that's at. And whatever that answer is going to be my y value. And so if I pull up my unit circle, I can pull it up somewhere. We'll go away. It's not in that one. It's not in that file. Try again. So if I pull up my unit circle and I'm looking at my y values, I want to figure out where I can get to a negative 1/2. And so I see that I get negative 1/2 in 2 spots. In 5 pi over 4, and I get negative 1/2 as a y value at 7, or at 11 pi over 6. Oh, 7 pi over 6 and 11 pi over 6. And I know that my y values can be in between negative pi over 2 and pi over 2 on my unit circle. That was my range. So if I look at negative pi over 2 to pi over 2, that's this circle right here. So I can only be on this part of my unit circle for sine. So if I'm only on that part of my unit circle, then the only value that works is 11 pi over 6. So then I know that y is equal to 11 pi over 6. Because remember, sine always refers to your y value. So let's do another one. So I'm looking at the inverse sine of the square root of 3 over 2. And I know that sine is always equal to my y values. So I'm going to set that equal to y. So then to get rid of an inverse sine, I take the sine of each side so that those cancel. So I'm left with the square root of 3 over 2 is equal to the sine of y, which tells me that I need to figure out when my sine graph equals the square root of 3 over 2. And I know that the inverse of sine only exists on the right-hand side of my circle. So I can ignore this whole side of my circle because inverse sine doesn't exist over there. It only exists in this part of my circle, and so I'm looking for the square root of 3 over 2. And so if I ignore that side of my circle, I notice that the only way that y is square root of 3 over 2 is at pi over 3. So that tells me that y has to equal pi over 3. Okay, let's do one more. So sine of negative 1 equals 2. And so if I set that equal to y, I get sine of negative 1 of 2, inverse sine of 2 is equal to y. So in order to get rid of an inverse sine, I take the sine of each side. So 2 is equal to sine of y. So that tells me y equals wherever sine is 2. So if I pull up my unit circle, and I'm looking at just this side of my graph, I would need to find a sine value equal to 2. So if I look at my y values on this side of the graph, I need to find one that's equal to 2. Do we have any sine values that are equal to 2 on this side of my graph? No. Okay, so that tells me two things. A, y does not exist. There is no y value that will ever give me a sine equal to 2. I also knew that to be the case because my range was always between negative 1 and 1. And so if I'm always working in between the constraints of negative 1 and 1, 2 doesn't exist between negative 1 and 1. So since 2 does not fall in between negative 1 and 1, it does not exist. we'll just do a few more. So arc cosine of square root of 2 over 2. So in order to get rid of an arc cosine, we have to take the cosine of both sides. And cosine always refers to your x value. So I'm setting that equal to x. So I'm going to take the cosine of x. Then my arc cosine and my cosine cancel because those are inverses. And I get the square root of 2 over 2 is equal to the cosine of x. So we're going to pop back to my unit circle and I erase all of this. What was my range that was available for my cosine graph? Where could I be? Negative 1, okay, what was my domain? Sorry. Is it 0 to pi, right? Yep. 0 to pi. So I know that I can only exist from 0 to pi. 0 to pi. So I'm only looking at the top half of my graph for cosine, which tells me I ignore everything on the bottom. Nothing on the bottom exists for cosine. And so if I'm looking for the square root of 2 over 2, and I'm looking at just my x values, I have square root of 2 over 2, and I have square root of 2 over 2. Up top, I only have it up here. Oh, that's my y value. If I'm looking at just my x value, square root of 2 over 2, I only have square root of 2 over 2 exist once. Where does square root of 2 over 2 exist from my cosine graph? Pi over 4, exactly. So then I know that x is equal to pi over 4. Okay, let's just do one more. So cosine, inverse cosine of negative 1. Cosine always refers to your x value, so I'm going to set that equal to x. And then I'm going to take the cosine of each side. When I do that, my cosines cancel, and I get negative 1 equals the cosine of x. Okay, so then if we look at our unit circle, we're looking at just the top half of our graph, and I need to figure out when my x value is negative 1. Okay, and so what radian measure is that? What would my x be? Pi. So I know that x is equal to pi. It only appears at negative 1 once, so x is pi. Is it starting to make some sense? Kind of. Okay. Let's see. We'll skip that one then. I'll go on to tangent. So I'm given arctangent of 0. And tangent, I'm just going to set equal to some random letter because tangent isn't actually a letter that appears on your graph. Tangent is always y over x. So I'm just going to set it equal to b. You would use a or c or z or whatever you want to use. So then if I take the tangent of each side in order to get rid of my inverse tangent, those cancel and I get 0 equals the tangent of b. And so let's figure out where our tangent graph exists on our unit circle. So what was our range for our tangent graph? Perfect. Okay, so negative pi over 2 to pi over 2. So just like my sine graph, my tangent graph only exists on the left half of my graph.
Why would I do that over?
On the,
Yeah, but that's pi over 2.
it's always positive part of your graph. So we're starting with the positive part of our graph. And I know that tangent I'm looking for 0, and tangent is always y over x. And so hopefully I think most of you probably wrote your tangents on your unit circle. This one doesn't have them. So where does 0 exist for my tangent? At 2 pi. Yep. So 0 exists here because 0 divided by 1 is 0. So then I know that b is equal to 2 pi. Okay, so if your tangents aren't on there, you might want to write them on there because it's easiest to just look at one thing to find it. So inverse tangent of -1. Let's use m this time, since I can use any letter I want. So inverse tangent of -1 is equal to m. So that tells me tangent, if I take the tangent of each side, then that leaves me with -1 is equal to tangent of m. So I'm looking for -1 on my graph. So if I come using just this circle, where would -1 exist on my tangent graph? 7 pi over 4, very good. Negative square root of 2 over 2 divided by square root of 2 over 2 simplifies to be -1. So I know that tangent of m equals -1 is at 7 pi over 4, so that tells me that m is equal to 7 pi over 4. Alright, does that make sense? Do we want to do one more? Very good. Makes sense. Okay. So you guys are going to work through page 347, 5 through 20, and 5 through 20 you're going to pull your answers off your unit circle. On 23 through 26, it has you estimating them using your calculator. So you're going to use your graphing calculator to plug that in for 23 through 26.